I am Murigeshwari, Associate Professor of Biomedical Engineering, Hindustan College of Engineering and Technology, Coimbatore. So now we see about the blood flow meter. Before the blood flow meter, we can see the blood flow. What do you mean by blood flow? An adequate blood supply is necessary for all organs of the body. An impaired supply of blood is the cause of various diseases. The third one is the ability to measure the blood flow is the vessel that supplies a particular organ would therefore be a great help in diagnosing such diseases. Blood flow is the rather elusive variable that cannot be measured easily. So methods used in industry for flow measurements of other liquids like the turbine flow meter and the rotometer are not very suitable for the measurement of blood flow because they require cutting blood vessel. So the types of blood flow meters. All blood flow meters currently used in the clinical and research applications are based on one of the following physical principles. So the number one, electromagnetic induction. Number two, ultrasound transmission or reflection. Number three, thermal convection. Number four, radiographic principles. Number five, indicator dilution. So here some of the magnetic blood flow probe. The first one is a large and small lumen blood flow probe, and the second one is a blood flow probe clip-on type of used during the surgery. The third one is a extra blood flow probe. So see the diagram for magnetic flow meter. Based on the principle of magnetic induction, when an electric conductor is moved through a magnetic field, a voltage is induced in the conductor proportional to the velocity of its motion. Same principles applies when the moving conductor is not a wire, but the column of conductive fluid that flows through a tube located in the magnetic field. A permanent magnet or electromagnetic position around the blood vessel generates the magnetic field perpendicular to the direction of the blood flow. The voltage induced in the moving blood column is measured with the stationary electrode located on opposite sides of the blood vessel and perpendicular to the direction of the magnetic field. So for magnetic field, the slip-on C-type is applied by squeezing an excised blood vessel together and slipping it through the slat of the probe. Contact is provided by two slightly producing platinum discs that touch the wall of the blood vessel. The interface of the probe must fit tightly around the vessel. Probe of this type are manufactured in sets with the diameter increasing in steps of 0.5 or 1 mm from about 2 to 20 mm. So currently magnetic blood flow meters use electromagnet driven by alternating currents. Change of the magnetic field causes the transducer to act like a transformer and induces error voltages which often exceed the signal levels. For recovering the signal in the presence of the error voltage, amplifiers with large dynamic range and phase sensitive or gated direction is used. The gated detectors is used. To minimize the problem, several different waveforms have been advocated for the magnetic current. Okay, some of the waveforms. The first one is the magnetic current and the second is the induced voltages, and B is a square waveform, then the C is a trapezoidal waveform. You see the diagram of magnetic blood flow meter. So next move to the ultrasonic blood flow meters. A beam of ultrasonic energy is used to measure the velocity of flowing blood. So these are done in two ways. One is a transit time ultrasonic flow meter. So in this step, a pulsed beam is directed through a blood vessel at a shallow angle and its transit time is then measured. If blood flows in the direction of the energy transmission, the transit time is shortened and vice versa. The Doppler principal ultrasonic flow meter. This is the more common ultrasonic flow meters. You see the diagram of the ultrasonic blood flow meters. So in this type, an oscillator operating at a frequency of several megahertz excites the piezoelectric transducer. Transducer is computed to the wall of the exposed blood vessel and sends the ultrasonic beam with the frequency F into the flowing blood. A small part of the transmitted energy is scattered back, is received by a second transducer arranged opposite The first one, since the scattering occurs mainly as a result of the moving blood cells, the reflected signal has a different frequency due to the Doppler effect. Its frequency is either F plus Fd or F minus Fd depending on the direction of the flow. The Doppler component of Fd is directly proportional to the velocity of the flowing blood. So in this method we can measure the velocity of blood flow in our body. So first one is a magnetic field effect, then the next one is a ultrasonic field using the Doppler effect. Okay, thank you.